Greetings, this is Mark Anderson for Kellogg Community College, and we are going to look at some of the first rules of factoring. We're going to look at getting a common factor, and we're also going to look at factoring by grouping. So the first rule of factoring, and the most important step, is to always look for a common factor, and then factor it out. By looking for the common factor, what you'll be able to do is make your problem easier, because at some moment of time you will have to do some factoring, and you would rather do it with the lowest power possible or with the smallest coefficients in front of your numbers as possible to help you along with that strategy. So I'm going to do 3 examples up here to show you what you will get in a common factor and what you can do with it. So for this first example here of 9x cubed minus 3x squared minus x, the common factor that's the easiest to see is that all of these share an x term, or x to the first power. I can factor that out by bringing that out to the front of our new trinomial. What this means is that I can reduce each of these by a power of x, or dividing x by each of these terms. Now, some of you might say that, well, 9 and 3 can both be divided by 3, but there's a 1 in front of this x, and 1 is not divisible by 3, and we're only going to look at factors that work out with integers for our leading coefficients. So if we factor out an x, this leaves me with 9x squared minus 3x minus 1. A common mistake sometimes is that if we feel like we can factor out an x, there would be a 0 here, and that's actually not the case, because x divided by x is x to the 0 power, and by definition x to the 0 power is 1. So each of these terms in this trinomial got 1 degree less big. So the 9x squared was a 9x cubed, the 3x was a 3x squared, and the 1 was a 1x. Looking down at our second example, we not only have x's that we can factor out, but we also have numbers we can factor out. And since we want to basically make our trinomial, or any kind of thing inside binomial, trinomial, or any other higher number of terms inside this polynomial, we want this to be as small as possible. So when you're looking at the leading coefficients, you might say, oh wow, I can divide each of these by 2, but you really could go bigger, can't you? Can't you find a bigger number that divides 16, 40, and 24 evenly? And sure you can. That would be an 8. Factoring out an 8x to the third power would allow you to remove 3 x's from each of these power of x's, and it would also allow you to divide each of these by 8, or divide everything by 8x to the third power. So that would leave me here with 2x to the 5th power, because 16 divided by 8 is 2, and x to the 8th divided by x cubed is x to the 5th, because we would subtract these corner coefficients when dividing exponents. Now we're looking at the second one. 40 divided by 8, that is going to be a 5, and then x to the 6th, dividing x cubed from that would be x cubed, because 6 minus 3 is 3. And then the final term here, this would be minus 3, because 24 divided by 8 is 3, and this is a subtraction problem, and x cubed divided by x cubed is x to the 0, which is 1. Negative 3 times 1 is negative 3. For my final greatest common factor problem, one of my tips as your math coach, as someone who has done math probably longer than you, you are going to want to try to factor out a negative if the first term is negative. As we will see in the problems below and in other trinomials where the first term is negative, it's just easier to deal with the first term being positive. This is an option, but as someone who's been around the block with mathematics a little bit, I strongly recommend you factor out a negative. So what number divides negative 42, positive 18, and negative 24? That's not 2. Yep, 3 works as well, so does 6. So we're going to factor out a negative 6. And if you look, there's x to the 5th, x to the 4th, x cubed, so we can only remove 3 x's from these 3 terms. And then here's y squared, y to the 5th, and y cubed, so we can only remove 2. You can see that we can only remove the smallest number on the power side for these to work here. So what we're going to have here is x to the 5th, I'm going to take this whole thing. So negative 42 divided by negative 46 is a positive 7. And then if I divide x to the 5th by x cubed, I get x squared. And if I divide y squared and y squared, that gives me y to the 0, which is 1. Minus. I'm going to then, so I'm going to divide the 18 by the negative 6, and that gives me a negative 3. And let's see, I have x to the 4th divided by x cubed, which is x, and then I have y to the 5th divided by y squared, which is y cubed. Alright, so for my final term, I'm going to put a plus because I have negative 24 divided by negative 6. And I have y cubed, or x cubed divided by x cubed, which is x to the 0 power, which is 1. And y cubed divided by y squared, which is y to the 1st power. And no, we don't put the 1 in the corner. Don't do that. We don't leave 1x or x to the 1st power in our final answer because that's fully, that's not fully simplified. Let's leave it that way for this level of class. Okay, so that is greatest common factor. We are now going to look for the second half of this video, second part I should say. We're going to look at grouping. And the second technique that we will actually use in some of our more difficult problems is going to deal with grouping because this is a step that we will use when we have 4 terms. And there's actually a type of factoring I'm going to do with trinomials. I call them tricky trinomials. That's going to involve this technique of grouping. And what we see in a grouping problem is that if we look as hard as we can, there is not going to be a single letter that's in all 4 terms. Notice the letters A, B, C, and D in this 4-term expression are actually not in every single term. We can't factor out an A, a B, a C, or a D out of all 4 terms. But when we have 4 terms, what we should look is for grouping. And so this is kind of doing the greatest common factor, but only like one part at a time. So we're going to look at the first 2 terms and factor out an A, and that gives me a D plus C. And here I'm going to factor out of these 2 terms what they have in common, in this case a C. Now I'm going to write the plus C there. I'm going to write the plus C and then leave this with D plus C. And now what you see is that I have this kind of interesting synergy here. I have this D plus C that's actually a match between these two things that I've factored out. Now this A plus C, I am going to write that A plus C only once, and then I'm going to write the D plus C only once, and then ta-da, it works. There's the factored form. And yup, this is where you should be going like, what kind of wizardry is this? And it's actually, I can show you through FOIL that this actually works. Now that's not an explanation, it's just showing you that if you do FOIL, which is first, outside, inside, last, where you multiply A times D, which is AD, sorry, that looks like a small d there, and then the outside, which is A times C, okay, and then the inside, which is C times D, and then the last terms, which is C times C, or C squared, you see we get back to the original. And so I think a lot of you are probably going still like, well, why does this actually work? But if I showed you a more simple problem, like A times the quantity of B plus C would be AB plus AC, I think there's a lot of understanding with that. But now instead of having just a single term here, A, why don't I have a binomial like A plus C, and then you can see that this would actually FOIL out and work as well. So this is an application of the distribution property going from here to here, because this is really the A plus C multiplied by the D plus C. Rearranging this using some commutative properties could also explain this as well, but this is really not the point that you want to see. What you really want to see is this pattern over and over again so you can apply it yourself. I'm sure there are better YouTube videos that explain how I got from this wavy line to that wavy line, but I'm not going to try to do that to you. What I am going to try to do is notice my blatant music joke. See, AC, DC, yeah, okay, there you go. Alright, so now let's get to another problem where we're going to take the first 2 terms and factor out a b squared, because we can factor out a b squared from both of those, so that's b minus 1. And here I'm going to factor out what they have in common. In that case is going to be a2, and that makes this a b minus 1. And you know what's great about grouping? It's that if you get the same binomial, then you're pretty much on the right track. I mean, you write whatever else is left outside, write that once, and then write this on the inside like that, there you go. There's your FOIL. And yes, I think you probably should FOIL. I mean, if this is something that you're a little nervous about, FOIL it out and make sure it gives you this original 4-term problem. All right, so we're going to ratchet things up a little bit with the next problem. We're going to take the first two and group out an a squared, which leaves me with an a minus 3. Now you got to be a little careful. When I factor out a common term of here, remember my coaching tip in this video? You should try to factor out a negative. Because if you factor out a negative 2 instead of a positive 2, then you get the a minus 3. And yes, you need the match. You need the match. You need the match to make your a squared minus 2 and your a minus 3, and then FOIL that back to make sure it works. Now, one other question that might have been in the back of your head is like, well, what if I wrote this down as a minus 3 and, you know, if I wrote it this way, a minus 3 and a squared minus 2. Would that be okay? Well, absolutely. Sure, it's okay. Because if I FOILed that out, it would give me this. I just prefer writing it this way because that would actually land the FOI cable in that order. So for our final 3 problems here for this video, let's take this up in difficulty here and take us to this problem here where I'm going to factor out whatever I can. That would be x squared, so that would be x minus 1. Now you're looking like, well, geez, what are you going to factor out of these 2 terms here? Well, the only thing you can factor out, because they have nothing in common, which is a 1. And oh my goodness, now you probably have that reminder that your teacher said to you in high school or middle school, you shouldn't factor out a 1 because it doesn't do anything. And you're right, it doesn't do anything, but in this case we need to do it because we need to have that match. And that match is going to leave me with an x squared plus 1 and an x minus 1. And that's the end of the problem. And for those of you who are looking at that x squared plus 1 and thinking, ooh, I could probably do something to that. No, you can't, because that's a plus, and that's going to be described in my difference of squares factoring video. So problem number 5. Oh, boy, the book was trying to trick you, weren't they? Well, you'll notice that this is not written in descending power. You see, if we rewrite the problem using the laws of commutativity, because you know, you can move things around with the commutative property as long as you kind of keep the positive and negative values applicable to them. Notice how the minus x to the 5th is here and the minus 1 is here, positive x. Now we can do our little groupy grouping. So here we have x to the 5th and here we have x minus 1. And there's nothing to factor out of these 2 terms, so we factor out a 1, and that leaves me with x minus 1. And here we go. We got x to the 5th plus 1. That was what was on the outside, and what's on the inside is x minus 1. And I'm not going to teach you anything with this x to the 5th power about factoring, so we're going to just leave it like this. So for our final problem, our final 4-term problem that should cause you some problems if you forgot the first rule of factoring. If you forgot the first rule of factoring, well, let me remind you that you should always look for common terms. The y's should have been maybe a little bit of a helpful hint to get you to think like, what do all of these have in common? Well, they all have one y in common, but also do not discount the fact that all of them have a 4 built into them as well. Haha. So by doing that, you'll notice that inside of these parentheses, I'm now going to have 4 terms, but the problem's going to be 4 times smaller. So if I divide by that, I get 4, I'm going to have just 1 y cubed, and I'm not going to write the 1 in front. Oh, I wish this pen had an eraser. All right, so there it is. I'm going to divide by 4, so this is going to be 3y squared. Divide by 4, this is going to be 4y. And this also, if I divide by 4, gives me a negative 12. Notice there's no y on the end because all of these drop by a power. Okay, so here's what I'm going to do. I'm going to keep the 4y dragging along here, but I'm going to start grouping this. Since I have 4 terms, I'm going to see if I can pull a term out of here. And yep, I can pull out a y squared, and that leaves me with, in the parentheses here, a y plus 3. Now, what am I going to remove from these 2 terms? What do they have in common? Oh, check it out. I can remove a minus 4. And that's going to leave me with a y plus 3. Hey, now what I've got is I've got a match, y plus 3, and I've got a leftover y squared minus 4. So here's what I have left. The 4y I brought out in the first place. And then I'm going to have this y squared minus 4. All right, y squared minus 4. And then I'm going to have a y plus 3. All right. And we're done with that part of the problem. And for those of you feeling a little smug, like, oh man, I just watched this whole video and I knew all this stuff anyway. Well, did you catch this? Did you catch that binomial in the middle there? That y squared minus 4? Yeah, I can bring that and make it out to y plus 2, y minus 2. But what? Wait, where'd that come from? Well, that actually is going to come in a later video that I made called the difference of squares. So believe me, if you got to this point, I'm pretty happy about that. But what happened if you didn't factor out the 4y? You would have gotten an equivalent answer where one of these two terms would be 4y bigger. So for example, you could have, as a possibility, you could have 4y cubed, right, minus 16y, and then y plus 3. All right, that's a possible answer because you didn't factor out the 4y of the original problem, so here's, something you had left over inside there. And yes, you could have factored out a 4y here and put that in the front. Another possible answer is your y squared minus 4, and then your second term here would be 4y squared plus 12y. Yeah, again, you could factor out a 4y here and move it all the way to the front since multiplication is commutative. But again, you could have this, you could have this. My hope is you would have this. And if you're super duper brainy awesome, you could actually have done the difference of squares. But again, I have a video called Difference of Squares that I'll be making later tonight and posting a link to your Moodle page and in your emails probably. So thank you for watching.